To everyone. Welcome you all for this session again, one more time. Yes, now we are going to see the division process, right? So it is very important to know the basics of division. Before that, basics is basically the division. Division is based upon the subtraction, addition, and multiplication. All three combination is the division. That's how we feel it complex because it is a combination of all three operations. So basically addition is the main operation, right? And then again the second one is subtraction. That's how we learn. And then multiplication. These are direct operations. Means if I want to add 2 plus 3, I'm getting 5, right? If I'm subtracting 7 minus 2 is 5. If I'm multiplying 3 times 4 is 12, right? So these are all direct operations. But when I'm doing the division process, it includes, initially it includes the one of the things, right? Mainly it is a repeated subtraction. By definition, by definition, the division is repeated subtraction. Division is repeated subtraction. That means, suppose if my number is there, let us take, yeah, this is basically about the basic idea. The definition of the division is it's a repeated subtraction, right? So let us see how to do that. So suppose my question is 9 divided by 3 is there. So if I keep on subtracting 3 from 9, how many times I can subtract? The meaning of this is, the division meaning is repeated subtraction. Repeated subtraction. That meaning is 9 divided by 3, how many times I can subtract 3 from 9? That is 9 minus 3, first time subtraction, I am getting 6. Then 6 minus 3, I am getting 3. And 3 minus 3, I am getting 0. So from 9, I could able to subtract 3 times. 9 minus 3 minus 3 minus 3. So that my answer is 0. Sometimes the answer may be 1 or something. So I'm repeatedly subtracting a number. That's how I'm calculating this as a division, right? So if I take out common minus, so what will happen? It is same as 3 plus 3 plus 3, right? So that's how we are getting 9 minus 3 times 3. So whatever the number of times that we are subtracting, so that the resultant should be less than the divisor. So this is called divisor. This is called dividend. And because 3 times I am doing the subtraction, so whatever the 3 times I am doing, sorry, 1 second. One second. Sorry, some person is getting in, unable to come in, so I just assisted him to get in, right? So now the dividend and divisor, whenever we are dividing two numbers, whatever the number that we are going to divide, that is called dividend. And by which number we are dividing, that is called the divisor. And how many times we are adding so that the division is happening, So let me take another example. This is about basically about how the division starts with, right? I hope everyone is clear with this thing. Many of us know the division directly, but where it starts and how it is happening, it is very important, right? So if my number is, let us say, 12 minus 3. So so it's 12 divided by 3 or 13 divided by 3. That is the best example I can take. 13 divided by 3. This is the question. So 13 is called the dividend. 3 is called the divisor. And when we are doing the division, the meaning of this is 13 minus 3 minus 3 minus 3 minus 3. 4 times I can subtract, and then I will get 1. Further I cannot subtract because 13 minus 3 is 10, 10 minus 3 is 7, 7 minus 3 is 4, 4 minus 3 is 1. So I cannot subtract 1 from 3. So that's how I had subtracted here 3, 4 times. If we observe this 13, if I'm taking subtract common, so this is 3 plus 3 plus 3 plus 3, right? So which is same as 13 minus 3 we are writing 4 times. So 3 times 4. 4 times 3, sorry. We are writing 3, 4 times, right? So, and what remains is 1. So, this 4 is called quotient, and this 1, whatever the remains, that is called remainder, right? So, this is very important when we are doing the division process, to know the terminology. It is very important to know the terminology. So when 13 is divided by 3, generally we write like this: 13 is divided by 3, 3 fours are 12, 1 remains. So this 13 is called dividend, 3 is called divisor, 4 is quotient, 1 is remainder. Also we can write the dividend as dividend is equal to divisor times quotient plus remainder. In the sense, if I'm writing 13 is equal to divisor is 3 times quotient is 4 plus 1. 3 times 4 is 12, 12 plus 1 is 13. So this is the basic understanding of how the division process started. I hope everyone is clear till this point, right? So if you have any questions, you can raise your hands. Any small question to the extent that I know it, right? I will try to answer. So many small things we take it for granted, but many a times we miss it, right? So if you have any questions, please please you can ask at any point of time, right? Okay. So moving ahead. So this is all about the division process. So now coming to the Vedic methods. So let us start from the basic again, the division. Okay. One is horizontal division. Means when we are going to divide, let us say the same sum I'm taking 13 divided by 3. So my quotient is 4, remainder is 1, right? This you have to do it in the mind. So basically, most of the times what happens is whenever we are calculating the things, in Vedic mathematics, we are going to do in the mind, right? So I will show it to you how exactly it is happening on the other way around also. But you have to start assuming that 3 times 4 is 12, 1, right? You are subtracting. So 4 is your quotient and 1 is your remainder. So you should be comfortable, very comfortable at this level. If you are not comfortable at this level, I think this session will not be suitable for you, right? So the more comfortable you are at this level, 13 divided by 3, quotient is 4, remainder is 1, without writing in this format, right? So just by observation, you should able to write this much. So this is the basic qualification to be in this class. So if at all anybody is finding difficulty, the questions may be like 25 divided by 6. So quotient is again 4, remainder is 1. 75 divided by 8. 8 nines are 72, remainder is 3. Right? So generally in my class, I generally used to give the questions. It will be an interactive session. It is not that Ramesh is speaking so much and then you are listening. It is not like that. It is a very, very much interactive class, right? So I keep on asking you the questions. I will give you so many questions in the thing. So you have to answer in the chat box. So your chat box, keep it open. And whenever my questions are there, I want you to answer it in the chat box, right? So I hope in this class, all people are comfortable with this part, right? Is everyone comfortable with this part, or any questions are there here? So if you are not clear, uh, I request you, means you can be there, there is no problem, but we cannot clarify the doubts at this level, right? So please make sure that you are understanding clearly at this level. This is the basic criteria to be very clear, right? Right? So you to be in this session, because we are going to see big divisions and all in one go. So it is not possible if you are not clear at this level, right? So it is a division class which is at a little higher level. So if you are starting from the beginning, it is different, but because we are going at a higher level, so I recommend you to be very clear at this level, right? Thank you. So I'm seeing that many people are commenting it. It is very nice. Thank you very much. Please keep commenting, right? So this is about the basic division. So I'm going to give you a few problems now. I want all the participants to be very interactive and keep writing the answers in the chat box. So I want only the quotients. I don't want the remainders, right? So suppose if my questions are 3 divided by 2, 5 divided by 2, 18 divided by 3. So I want only quotients. I don't want remainder 1, 2, 6 like that, right? So you can write the answers with either comma or full stop, whatever you want, right? So write all the answers in one go and press enter. That will be better so that I can see the things. And then it will be a single shot, right? Okay. I hope I'm clear at this point. Let me go ahead. Now you're going to write the quotient, right? Now, my question starts. It is not important who is writing first, right? Because, yeah, Sharada. Yeah, Sharada Garu, if you have any question, I think I can unmute you or somebody can unmute you so that we can. What is your question? Can you, who can unmute you? Ravani. Okay, anyhow, let me start with, right? I will take up your doubts. Please keep it, I will take it, right? Okay, I'm writing the questions 1, 2, 3, 4, 5, 6, right? So I want you to write all the answers, put commas in between and write the final answer, right? So it is important to write the correct answer. It is no competition. Who is coming to first? It is not a competition. It is about understanding and typing it in the chat box, right? So no hurry, right? You need not submit it fast, right? So I want you to understand and write it correctly. That is more important, right? Now the question starts. Only the quotient. I don't want the remainder. So, yes. I want you to write with commas so that there won't be many answers. It will be easy for me to see. If you are keep on writing one answer, it will be difficult. The scroll will go very fast, right? So I cannot see the chat box so fast. I'm writing here. So I want you to write, yeah, with commas or something like that. Any difference you can make it because it is only single digit you have to write, right? So I hope everyone is clear with this. Where let me change the color and write the answer. So 4 threes are 12. So 3, 6 eights are 48, and 2 twos are 4. And 7 divided by 9, it cannot be divided. 0 is my quotient here. 8 divided by 3, 2 is the thing. 7 divided 59 divided by 7 is 8. So 382028, right? So very good. Many of you are answering correctly, right? Good. Now let us go ahead. I hope everybody has completed this, right? Because it is very difficult for me to see everyone is doing it or not because so many people are there. So make sure that you are doing the sums, right? So the participation is more important. I'm telling you, the more you participate, the more you will learn, right? So in the second category, where we are going to write only the remainders, right? So you are going to write only the remainder. I don't want any quotient. I want only the remainder, right? Again, I'm going to give you 6 questions. Right? So I want you to write remainders, placing commas to next one. And then if possible, you can change it to privately. So generally, I don't think that somebody will copy you. But if you feel that insecurity, you can put it yourself as privately so that others cannot see your questions, right? So the answers here are because 4 threes are 12. After reducing 12, my number is 2 in this case. In this case, it is 3. In this case, it is 7. In this case, it is 0. In this case, it is 3. In this case, it is 5. So 237,035, right? Oh, good. How many of you don't know the Vedic division till now doesn't have any experience related to Vedic mathematics? Can the people can raise their hand or inform it in the chat box? My question is, till now they don't have any experience in Vedic method of divisions. Are some people are there though they don't have any idea about Vedic mathematics? Okay. Yeah, it's okay. Miss, basically, my question is those who are not yet tried the division, right? So although you know very well, some of you, because there are many participants are there, So I'm going very slow at a very sequential path, right? So I want to, it is even one person is there, we have to take care, right? So I want everybody should learn uh, in a better way this thing, and then we can go ahead, right? Okay. So let us move ahead. Now we will move on to the where the quotient digit is a two-digit number. Divisor is one digit. Okay. So many of us do in this fashion, but let us see that generally how to do it, right? Now my question is, let us say 235 divided by 7, right? So normally what we do is 235 we will take, we divide it by 7, 7 threes are 21, 2 remains, and we drop down 5 here, and again 7 threes 21, and 4 remains. So 33 is my quotient and 4 is my remainder. This is the general procedure that we know. But here in the first step, in the step 1, I'm going to divide 23 by 7, and my quotient is 3 and remainder is 2. So quotient 3 I write it just below this, and remainder 2 I passed as 20, right? Remainder 2 I passed as 20 here. So now the next process that I'm going to do is 20 plus 5. This is very important. In the second step, I'm going to add 20 plus 5, whatever the remainder, that times 10 plus 5 divided by 7. So again, quotient is 3, remainder is 4. So the quotient when 25 is divided by 7, quotient is 3, and the final remainder is 4. So 33 is my quotient and 4 is my remainder, right? So in this process, what we are doing is when the first division is done, whatever the remainder is there, that we are passing it as 20, right? So now the question, why 2 passed as 20, right? So, so we should always think whenever we are writing, why 2 passed as 20? So the answer is on the left hand side, where if we observe the 2 here, if we expand this number, this is same as 20 plus 5. We observe that on the left hand side I have written the general expression. In this, whatever the 2 we are taking, the 2 is in tens place of a number. We are taking 2 in the tens place of a number. So when we are taking the 2 at tens place of a number, then then uh, that's how it becomes 20. The 2 becomes 20 because whenever we are passing from lower place to higher place, that means if my 2 and 5 are there, so here 2 means 20. So when I'm passing this to units place, when I'm passing this to, this is tens place, right? And this is units place. So when I'm passing any number to the one digit next to it, it will be passed as 10 times. That's how we are getting 20 here, right? It will be taken as the 20 plus 5 is 25. And then we are going to divide, right? I hope you are clear at this point. Why I had written 20. So if you have any still difficulty, you can ask me. Okay, I hope everyone is clear with this. Four 37 divided by 6. So here my quotient digit is 6 sevens are 42. 1 remains, passed as 10. And then next digit, I am seeing this as 17. 17 divided by 6. 6 twos are 12. 5 is my remainder. So quotient is 72 and 5 is my remainder. Right? I hope everyone is clear at this point. Let me do one more sum. 527 divided by 8. So 8 6 are 48, 4 remains, 8 5 are 47 remains, right? So this 40 we are not going to write. This 40 I am writing just because it is there in my mind. You cannot see that as 47 if I am not writing 40, right? But if you observe, when you are doing the calculations, you need not write that 4, right? You can just observe and write the answer. Okay. I hope you are clear with this, right? Next one, next one is 302 divided by 6. So 6 5s are 30, nothing passed, so 0. 2 divided by 6. It is very important to write the quotient here. So the quotient is 0, remainder is 2. So if you are leaving just 5 and remainder as 2, that is your wrong answer. So whenever you are passing the digit, you must divide. That's how 2 divided by 6 quotient is 0. So it is very important to write the quotient and remainder. When 2 is divided by 6, 6 zeros 0, 2 is the remainder. So 0 is quotient, 2 is remainder. I hope you people are clear with this, right? Good. So if you are clear, then we'll start with the questions again. So I want only the quotient, right? So here you need not write the questions, right? So you can directly write the answer in the chat box. That's it. So keep putting commas between the different answers and keep writing the answers in the chat box. Okay. Is that clear? My instructions. So here you need not write the question. You need not write the pass-on number. You are just observing it and you are writing it in the chat box without pen and paper. To the extent possible, those cannot do it, that is different issue. But our mind is very powerful. The more you train in that direction, the more it will work in that direction. So it is very important for you to train your mind in that direction, right? So you should train your mind in that direction. So when you keep training your mind in that direction, so automatically it will start working, right? So so that you can do any calculations in that. If you don't allow your mind to work in that, initially there may be mistakes. You may do mistakes. It is okay. Means when you are doing mistakes 2 3 4, if you want to learn it, initially there may be mistakes, but uh, but you will learn it. Once you learn it, the mistakes will get reduced. So at the initial stages you may do the mistakes, but that's how. Don't be hurrying doing the things. Understand and take your time. Without pen and paper, you're going to write the quotient for each one of these, where quotient is a 2-digit number, right? Okay. Now your question starts. 436 divided by 5. 374 divided by 7. 218 divided by 6. 547 divided by 8. 354 divided by 7. 218 divided by 6. 547 divided by 6. 547 divided by 7. 218 divided by 6. 547 divided by 7. 218 divided by 6. 547 divided by 7. 218 divided by 6. 547 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 divided by 6. 354 divided by 5. 679 divided by 8. So these are some of the questions for you. So you can divide and you can write the quotients of these numbers. You can write it in the chat box. Yeah. So I hope many people are doing. So let me also do some of some of these for you, right? Okay, good. So 5 8s are 40, 3 remains passed as 30. So 5 7s are 35. 7 5s are 35, 2 remains passed as 20, 7 3s are 21. 6 3s are 18, 3 remains, 6 6 are 36. 8 6 are 48, 6 remains, 8 9 are 8 8 are 64. 5 divides 5 7 are 35, 0 remains 0. 8 8 are 64, 3 remains, 39 divided by 8 is 8 4 is 32. So 87, 53, 36, 68, 70, and 84. So these are my coefficients, right? So good, right? So you have to imagine, you have to understand the procedure, you have to apply the procedure, and you have to start writing the answers. So it is very important to apply the procedure and do in the procedural way, right? So that you can understand, you can grasp it, and then you can use it, right? So it is very important to do the questions in a particular, means whatever the way that your thinking process is going on, I want you to write in that direction, right? So here, to the extent possible, we are not going to touch pen and paper. Just by seeing the question, we are going to write the answers. So for some people, it may be difficult after some extent. Then we will see. Means to some extent, you can use the pen and paper. That is fine. But to the extent possible, you have to train your mind. The more you train your mind, the more fast it will work, right? So it is till now, whatever the way it is working, it is fine. But now we are going to train our mind. We will give the instructions without pen and paper. I am going to do this, right? So initially you may do mistakes. Again, I'm telling you, don't worry about the number of mistakes. Understand the procedure, try to improve it, right? So that you will improve it. Okay. Okay. Let us go ahead. Now, if this is extended to a 3-digit number, let us say, my quotient is a 3-digit number. So in that case, what will happen? The same procedure is extended for one more time. Let me take it. 1, 3, 4, 6 divided by 5. So I know that when 13 is divided by 5, in step 1, it is 13 divided by 5. So the quotient is 2 and remainder is 3. So my quotient is 2, remainder 3 passed as 30. It is just passed as 30 in my mind. The 30 is there for fraction of seconds. I don't want that actually. It is in a fraction of part. It is coming to my mind, observing that as 34 and move on. That's it. So you need not write actually 30 because all of you are very elderly persons. Many of you know the division well. So that's how I'm telling you. So it is important you to instruct your mind not to use pen and paper. So 5 6 are 30, because when 34 is divided by 5, 5 6 are 34 remains, 4 passed as 40, and 5 9s are 45. The final remainder is 1. So in the second step, we are 30 plus 4, 34 divided by 5, where quotient is 6, remainder is 4. And finally, we have 46 divided by 5, quotient is 9, remainder is 1. So 269 is my quotient finally, and 1 is my remainder. So I'm not going to subtract the things and all in between, right? So normally the subtraction, it's a lengthy process, right? So we do so much lengthy calculation, and then we are going to write the answers, right? So it is important to do in this way, right? Without pen and paper, you can just directly write the answers. So let us take ahead another example. Uh, 1438 divided by 7. So what will happen? 7 twos are 14, 0 passed. Either you can keep it as 1 0 or 2 zeros, it hardly matters, right? Because it is there in the mind for fraction of second, that's it. It is coming and passing, that's it. So 3 divided by 7. In the second step, we are going to divide 3 by 7. The first step, we are dividing 14 by 7, where quotient is 2, remainder is 0. And in the second step, it is 3 divided by 7. The quotient is 0, remainder is 3. So here generally some of the people may confuse. So it is very important 0 and past 3 as 30. And then 38 divided by 7. 7 5s are 35, 3 is the final remainder. Right? I hope everyone is clear with this, right? Good. Here 9 goes 2 times, 9 twos are 18, 5 remains, 5 passed as 50. So in the first step, we are subtracting 23 minus 23 is divided by 9, quotient is 2 and remainder is 5. 5 passed as 50. In the second step, it is 55 divided by 9, 9 6 are 54, 1 remains. So 9 6 are 54, 1 remains. And 17 divided by 9. Step 3, 17 divided by 9. 9 ones are 9 and remainder is 8. So 1 remainder, final remainder is 8. Right? Hope everyone is clear with this. Right? Here we are going to learn one more concept, that is called digital root concept, which is very, very important for verification purpose. If you want to verify that your sum is correct or not, then digital root is a very powerful verification technique. So in this, basically, when we are going to do this, so many of you might be knowing, have an idea about what is digital root. So it is basically when any of number is there, let us say, if a single digit number is there, the digital root is the same number. 4 is there, 4 is the digital root, that's it. Whenever a double digit number is there, like 23, you have to add the digits, that is your digital root. If my number is 75, I'm getting adding, by adding I get 12, but in turn if I add, I will get 3. So 1 plus 2 also will be added and getting 3. So it is very important that digital root is a single digit number, generally 1 to 9 or 0 to 8. Either it is 1 to 9 or 0 to 8, because here 9 is same as 0. Whenever you are taking, the important observation is whenever you are taking 9, which is same as 0. So suppose if 92 is there, so what is the addition of 92? 9 and 2. 9 and 2 is 11. In turn, it is 2. Means you are ignoring the 9. 9 works as 0 plus 2 is 2. 9 plus 2 is also 11, which in turn is a 2. So this 0 works as 9. 9 works as 0. So whenever your some calculations are there, so if the divisor is 9 or here both are 9s, right? So your remainder is 8. So what is the verification technique? You multiply these two and add this so that your answer should verify with this, right? So let me take a new paper and example and explain you the thing. So here I'm getting the quotient as 8 5s are 40, 56, 8 sevens are 56, 0 remains, 8 ones are 8, 1 remains. So these are the passing digits, so you just ignore them. So you have to find the digital root of this number. So whatever be the number of digits, you keep on adding the digits and getting one digit answer. So here when I'm adding it, what I do is wherever nines are there, I ignore the nines. So here I observe that there are two nines are there. So here the digital root is 6 only. For this, the digital root is 8 plus 5 is 13, 13 is 4. So 4 is the digital root here, 1 is the digital root here, 8 is the digital root here, 6 is the digital root here. By observing this, the rule is dividend is equal to divisor times quotient plus remainder. So what is dividend here? The digital roots I am writing. 6 is equal to divisor is 8 times 4 plus 1. So 8 times 4 plus 1 is equal to 6. So 8 times 4 is 32. When you are multiplying this, you are getting 32. And while you are adding 3 plus 2, you are getting 5. And then the 32 in turn is 5. And then 5 plus 1 is 6. So your digital root is matching with this, right? So it is important to see the digital root technique also when you're doing big problems, because when you're doing in the mind, the chances of doing the mistakes are there. So it is very important to identify those things and doing in this fashion, right? So this is all about the division that we are doing and getting the answers and doing the things. Any questions from any side? Okay. I'm going to give you a few examples here. Let me write it. Uh, uh, the digital root first. Let me take the digital root, right? So the digital root here, yeah, the digital root. Whenever I'm having a two-digit number, it is simple, right? 75 is there. 7 plus 5, 12. It is 3. Whatever big number, 4, 5, 6, 9. So wherever 9 is there, I ignore. 6 is my digital root, right? For the full number, I'm going to find the digital root. So I'm giving you here 5 numbers. I want you to find the digital root of all the 5 numbers. Okay. My numbers are 674, 289, 584, 613, 288. So I want you to write the digital roots for this. So with commas, you can write the digital roots. Zero or 9, anything you can write, right? So here the digital root is wherever 9 is there, we are ignoring. Again, I'm telling you the digital root of 674 is 6 plus 7 plus 4. So you have to 6 plus 7, 13 plus 4 is 17. You are adding the digits and then getting 8, right? So 674 is there. We are adding the digits and getting a single number. After getting that, if it is a double digit number, you are going to add the digits, still you are getting a single digit number. So my answer here is 8. But the way that I do is 6 plus 7 plus 4 is there. So 6 plus 7 is 13. Immediately I turn it into 4. So I will not add 13 plus 4. Wherever it is a two-digit number in my mind, I turn it into 4 and then do it. The other beautiness of digital root is when I'm finding the digital root of any number that is with 9 or the number adding up to 9, right? So the digital root here is 11, in turn it is 2. Here if you see 9 plus 8, 17, in turn is 8. So wherever the 9 is there, we ignore for the calculation, the digital root is directly you are getting, right? 6, 3 if you remove, 8 is your digital root, right? So in this case, 674, it is clear. And then 289, 9 cast out, 8 plus 2 is 10, which is 1, right? Vajanka method we are going to start tomorrow, madam. So today is a basic division class so that they can understand. So tomorrow is a single digit Vajanka and day after tomorrow it is a double digit Vajanka. So that's how we organized this lecture. So today it is a basic division only because almost the time is up. It is almost 7, right? So we are in the verge of finishing this. So, so tomorrow we are going to see the bigger divisions, right? I hope you are clear with this. Now let us do the divisions with a 3-digit divisor. Sorry, quotient is a 3-digit number, right? Divisor is 1 digit only. Divisor is for today, it is only 1-digit divisor, right? So I'm going to give you again 6 problems. I want everybody should write quotient and remainder, right? So after getting this, I will take the doubts, whatever questions you have, we will open the session for questions and then you can ask the doubts, okay? So I'm going to give you 6 questions. Quickly, you can finish it and then we can have a doubt session, right? So quickly you can do this. You can write the answers in the chat box, right? And after finishing this, I want you to verify your own, the digital root technique, dividend is equal to divisor times quotient plus remainder. Then you can do it later after completing the session, right? So, and then we will move on. So let me also write the answers. Now you might have started writing the answer. This I'm writing here, it's okay, right? So 6 5s are 30, 46. So 6 7s are 42, 48, 6 8s are 48, 0 is the remainder. sorry, 8 6 are 48, 60, 8 8 are 64, 30, 8 4 are 32, 2 remains. I'm writing all these because you can understand, right? So you need not write the passing digits. You can directly, by seeing the question, you have to write the answer in the chat box or in your paper. You need not note down the question. So 7 3s are 21, 69, 7 9s are 63, 7 9s are 63, 60 again, 7 9s are 63, 1 remains, right? 4 3s are 12, 38, 4 9s are 36, 20 remains, 4 5s are 23 remains. 5 4s are 20, 36, 5 7s are 35, 10, 19, 5 3s are 15, 4 remains. 9 8s are 72, 2 remains. 9 2s are 18, 8 remains. 9 9s are 81, 8 remains. So these are my answers. So let me highlight with green color. This, this. So these are my answers. Hope you can do it and you can verify. So now the session opens for the discussion. 1 second. Okay, so now the session is open for questions. So anybody is having, please feel free to ask the question. Yeah, can you unmute Charan or somebody? Can you unmute all?
Yeah,
Or, or everybody mute themselves. Those who are asking, let them ask the questions. Maybe
okay, sir.
similar type of questions everybody is having. Yeah, please.
Isn't digital roots the similar concept as casting out of nines when we multiply? Sir, can you hear me?
Yeah, I am
I
here.
can hear you. Sorry, my mic is muted. Sorry.
So
I can hear you.
my question is, digital roots are similar as casting out of nines.
Yeah, it is part of getting the digital root. So casting of nines is you are just ignoring the nines in the part. Like if you want to find the remainder of a nine when the number is divided by nine, what is the remainder, right?
Correct.
So in that you are casting out nines wherever nines are there, you are cutting out, right?
Mhm.
So it is the process of getting a single digit number. In the process, you are cutting the nines. It is called as we can call that as casting of nines. Correct.
Okay.
Yeah.
Thank you.
Yeah. Any more questions from anyone?
There are
Hello, sir.
Yeah.
Sir, while writing 288,
Yeah.
while sir digital sum 288 digital sum లో
Yeah.
మీరు ఇక్కడ 9 గానీ 0 గానీ చేశారు కదా 9 ని
Yeah.
0 చేశారు ఎందుకు చేశారు
Yeah.
సార్ ఇక్కడ 9 0
See, when you are adding these digits, casting out nine means wherever nine is there, we can cut that and then we can write it zero also. So either way, both are same. In case of digital root, either you write nine or you write zero. Both are same. So
okay
some
okay okay
people may write zero, some people may write nine. So don't worry, both are same only. Because at the end you are verifying the answer. If you have one place you are see, suppose simple question if I am taking, let us say 13 times, sorry, 13 times 13 is 169, right?
yes sir
So 13 is not, no. 1 second. Let me take another example. Like 36 times 36 is 1296.
96
Right? So if you cast out 9, what will happen is you cut the number 0 times 0. Or if you are writing 9 times 9, it is fine. In the answer also, you cut out 9 and then you are getting 0. So writing 0 is much more faster, right? Rather than
Okay.
if you are keeping it 9 and multiplying with something again getting 9 and all, the zero operations are much more easier. So that's how in casting of nines and writing the digital roots, sometimes we may write 0, sometimes we may write 9, but both are same. You should know that both are same.
Okay. Thank you.
Hello,
Yeah,
sir. Hello.
yeah, చెప్పండి.
If we get LHS and RHS both are equal in digital route, can we say that the answer is correct?
Yeah,
Solution?
not necessary, not necessary. Suppose if I am writing this as 1906, right?
Okay.
So here also I am getting the digital root as 0 only,
Yeah,
right?
yeah.
Although it is not 0 times 0, that is different. So, but here the number doesn't vary. But here the rule is, if the digital root is wrong, then 100% your answer is wrong. There is some mistake in your process.
Okay.
If the digital root is correct, there is very less chances. See, till now I'm using this Vedic mathematics for almost 12 years of time, and then more than 12 years time, and then many places I applied the digital root techniques and doing the things and all. In Vedic mathematics, there is even clashes compared to conventional mathematics. But even then, the chances of getting the digital root correct, but the answer is wrong, is around 2 to 5%.
Okay. If in competitive exams like staff selection commission,
Yeah.
if two options satisfy like that, how
Yeah.
can you
Yeah.
follow?
Then there are two digital root techniques are there. There is one digital root technique called with 9, another digital root technique with 11. Right?
Okay.
Suppose if the same thing is there, let me check with the digital root with 11. Right? So digital root with 11 is, the 9 times 9 is 81. Right? 81 in turn is 9, because here the digit is 9 only. It is not exceeding 11. So if it exceeds 11, you can cast out, means you remove it. Otherwise it is with 11. So if I'm adding this here 9 plus 2, 11, I can ignore this. My digital root with 11 is 7 here. Are you getting my point?
Yeah. Okay. And one more small doubt, sir.
Yeah.
Actually, in Vedic methods, we can do from both the ends. So addition, subtraction, multiplication, we can do from both the edges. So can we do in division also? Is it possible?
Come again. Sorry, sir, I missed it.
Actually, in addition, subtraction, multiplication, we can do simplification from both the ends.
Yeah.
From left to right and right to left.
Right to left. But division is a process where you can do only from left to right. Right to left, I tried many a times with the means. First thing is, I never come across in any literature that somebody is doing the division from right to left. And I too tried many ways. It is at very initial stages only I tried. Means in the first 4-5 years I tried. Many a times I tried to do the division. It has not happened, but to my knowledge, there is no procedure from right to left. That procedure is there, very complex procedure. See,
visualization. Visualization.
It is very difficult. It means you can do it, but that much complexity, there is no point. Even that complexity, if you are doing, it is of no point, right?
Okay. Thank you, sir.
Hello, sir.
Yeah.
Sorry, Vedic maths lo, can I speak in Telugu?
Yeah, you can speak in Telugu.
Vedic maths లో జనరల్ గా ప్రతిదానికి కూడా కన్వెన్షనల్ ప్రూఫ్స్ అనేవి మాకు ఎక్కడ మనం స్టడీ చేయొచ్చు. ఫర్ ఎగ్జాంపుల్, ఒక అంత్యోదయ దశకి అపి అనే ఫార్ములా ఉందనుకోండి, దాన్ని మనం వెరిఫై చేయడానికి 10a + b × 10a + c అనే రాసి మనం జనరల్ గా వెరిఫై చేస్తాం. అలాంటిది ప్రతి దానికి కూడా ప్రూఫ్స్ కావాలంటే ఏమైనా అంటే బుక్స్ ఏమైనా రిఫర్ చేయడం లాంటిది ఏమన్నా మీరు సజెస్ట్ చేయగలుగుతారా?
ప్రతిదానికి అంటే ఒకటి, నా బుక్ లో నేను రాసినంత వరకు చాలా మటుకు ఆల్గారిథమ్స్ రాస్తూ ఉంటానండి. ఎనీ టైమ్ ఐ జనరల్లీ రిప్రజెంట్ ద థింగ్స్ ఇన్ algebraic way and see that to do some algebraic proofs, right?
Okay.
So but
maybe sir, you can refer Kenneth Williams. Yeah, he have written already. some few proofs, not total proofs. Kenneth Williams, Proofs of Vedic Mathematics, the book name.
ప్రూఫ్స్ ఆఫ్
Vedic mathematics.
Proofs of Vedic Mathematics.
సార్ మీరు
I-
రాసిన
I-
book రమేష్ సార్
Yeah, అదే చరణ్ చెప్తున్నానండి.
okay,
చరణ్
okay.
and me are together taking.
Joy of Vedic Mathematics.
My book name is Enjoy Vedic Mathematics.
Oh, sorry.
It is on the Enjoy Vedic Maths.
ఈజ్ ఇట్ అవైలబుల్ ఇన్ అమెజాన్?
Actually, I think it is available in Amazon. It is publishing by Art of Living. So it is not available in general stores. But yeah, the book is available in only few places. Art of Living places only it is available. I think it is available in Amazon. I think you can buy it.
నేను ఎందుకు డౌట్ అడిగానంటే జనరల్ గా ఇప్పుడు మేము వేరే వాళ్ళకి ఎవరికైనా చెప్పినాం అనుకోండి, దీనికి
Yeah.
ప్రూఫ్ ఏంటి అంటే మేము ప్రతిదానికి చెప్పలేం కదా, కొన్నిటికి
Yeah,
మాత్రం.
correct. So wherever you have any doubts, you can let us know, either me or Charan Lal. So we are so fond and working in this direction only. So if you have any doubts, any questions, something related to this, to the extent possible, we will help you out in getting the things done. Right?
థ్యాంక్ యూ సార్.
So if no more questions, then we will meet tomorrow, right? Tomorrow at the same time, 6 o'clock.
డిజిటల్ హలో ఎక్స్క్యూజ్ సార్,
Yeah.
తెలుగు మాట్లాడచ్చా?
Yeah. Definitely.
అంటే డిజిటల్ రూట్ అనేది ఒక్కొక్కసారి ఒక డిఫరెంట్ గా చెప్పారు కదా, ఎడిషన్ చేయాలా 3 నెంబర్స్ కి, ఇంకోసారి 9 కొట్టేశారు, వేరే చోట 8 వేశారు, ఇట్లా
Yeah.
క్లాస్ ఇవ్వండి.
ఎలా చేసినా సరే ఇప్పుడు 7, 9, 4 ఉన్నదండి. మీరు దీన్ని యాడ్ చేసిన దిస్ ఈజ్ 16 + 4 = 20. ఇలా చేసిన 9 కొట్టేసి 7 + 4 11 అంటే 2 చేసిన ఏదైనా ఫైనల్ గా వచ్చే డిజిటల్ రూట్ ఒకటే. దేర్ ఆర్ డిఫరెంట్ వేస్ ఆఫ్ గెటింగ్ ద నెంబర్, రైట్? సో మన ఇష్టం అన్నది అది. అంటే మీరు ఫుల్ గా యాడ్ చేసి చేస్తానంటే చెయ్యొచ్చు, మీకు కొంచెం టైం ఎక్కువ తీసుకుంటుంది. ఇది చిన్న నెంబర్ కాబట్టి అయిపోయింది. నేను ఇలా నెంబర్ ఇచ్చాను అనుకోండి, ఈ నెంబర్ వచ్చింది, ఈ నెంబర్కి డిజిటల్ రూట్ ఫైండ్ చేయాలి అంటే ఇన్ని యాడ్ చేసుకునేసరికి మనకు చాలా టైం పడుతుంది. అలా కాకుండా వేరెవర్ 9 ఈజ్ దేర్, 6, 4, 8 ఈజ్ ఆల్సో 9, అండ్ దెన్ 6, 4, 8 ఈజ్ ఆల్సో 9. So remaining are 7 and 3. I can write it the digital root in no time, right? So 9 కాదండి, 6, 4, 8 అలాగే. అంటే ఏదైనా సరే 9 table, right? So whichever is coming in 9 table, generally 18 is sufficient enough. So wherever 9s are combination or 18 combination, you can ignore, and remaining digits you can focus and get the things done, right? Yeah, we will list you the topics that we are going to discuss in the next week.